Hey everybody, Craig here, and today I'm going to be going through doing an installation of OKD4.4 on top of oVirt using the IPI install. So at the time of my last video, they just before I released it, they dropped a new beta pre-release of OKD4.4, which is awesome. Unfortunately, in the pre-release that they dropped, it broke oVirt support, which is why my installation video is a little bit delayed. I was hoping to be able to wait for another beta to drop, but it still hasn't dropped. I know that they're tagging new beta pre-releases. They're just not available in GitHub yet. But imagine when you come to do this, you take a look at GitHub, see what the current latest version is, and if it's not this, if it's not the one that dropped on the 28th of March, if it's beta 2 or beta 3 or even the actual release, then go ahead and use that. Otherwise, what we're going to do, and what I'm going to do for this video here, is to build off nightlies. So the nightlies are actually pretty stable. You can see that these are all of the OKD 4.4. I say nightly builds, they're not. They're builds whenever there's a change to any of the other components of Openshift. They do a build and they run a bunch of tests, and they also test upgrade path as well. So you can see pretty clearly whether or not you're going to have any issues with this. For the most part, I haven't had any issues with these, but obviously if you're going to run production type systems, don't do it with nightlies. Wait for the main release. But for the purpose of the video, the process is the same. You just grab your build stuff from your build artifact from a different location. So what we're going to do is we're going to go ahead and do a few things. So I've already taken the liberty of reserving some IP addresses on my network. So you're going to need a couple of things here. You're going to need your reserved IP address network. Let's hope I can cut that out. Okay, so to get started, we're going to need a couple of things. We're going to need to reserve 3 IP addresses on the network, and that's so that you've got an IP address for the API, the DNS, and the ingress load balancer. I had to think there. So we need 3 IPs reserving, and we put those into the config. I'll show you where in a second. We also need to reserve create some DNS entries. So in my estate, I'm running IPA, free IPA. It's great, dead easy to manage. And these are the 3 records that I've created. So I've got a zone called CWS land, which is where we're going to be putting our cluster. And I've called my cluster test 1. I'll show you where you call that in the config in a second. And so I've created star.apps.test1, API int.test1, and API.test1. So the API both point at the API IP address that you're reserving. The apps points at the apps VIP IP address that you're reserving. You'll notice we don't have an entry here for DNS. We don't need it. The installation itself, so OKD on top of oVirt is actually pretty good when it comes to managing a lot of the DNS and kind of virtual IPs and all that kind of stuff. I was expecting to have to do a lot more kind of pre-build work of setting up load balancers and things like that, as you do for other platforms or UPI installs, or for 3.11 for example. But the IPI installer for oVirt actually takes care of a lot of that, which is really good. It makes the installation really simple. So as far as that goes, so let me show you quickly. Actually, no, I'm going off script, so I won't do that. I've actually had to script this a little bit to try and keep me on track. Otherwise, I'll ramble. Okay, so first thing we're going to want to do, we're going to want to get the release. And to do that, all we need is the OC client. So I'm going to go over to here and just pick whatever the latest release is in GitHub. I'm going to go down to the assets here, and I'm just going to grab hold of the Openshift client. Now, it's down to you which client you grab. You know, depends on your platform. I'm running on Windows, but I'm using WSL over here, as in over here. So I'm just going to go ahead and grab the Linux client for this. You will need to install from either a Linux or a Mac, Linux machine or a Mac. The install doesn't work from Windows at the moment, as you can see here by the install binaries that are provided. Now, don't be fooled into grabbing the install binary. Although it's a bit counterintuitive, we don't need it yet. We're actually going to go ahead and generate one ourselves. So as part of my installation, because I'm going to be installing from the Ci registry, so the release .ci.openshift.org registry. This registry is a little bit unstable, and it gets cleaned up really frequently. As you can imagine, if they start retaining assets or artifacts for every single build they do, they're going to end up with a lot of containers, and that's going to grow in size very rapidly. So they tend to clear down the assets in the repository every couple of days or so. So just bear that in mind as you're doing an install. You can do the install from here, just directly from this registry, but you're going to run into problems after a couple of days running it, when you're not able to pull containers anymore. So I personally am mirroring for my own installation, mirroring that repository. There's actually good installation. I'm just going to pull them up in another window here, but there's good installation guides. Don't know why I went to the Amazon docs. I don't want the Amazon docs. I want OpenShift docs. There's a really good installation guide on how to set up a mirror of a registry on the OpenShift docs. I'll bring this over here just so you can see what I'm doing. Here we go, creating a mirror registry for a restricted network. So if you follow these instructions, you're gonna be in a pretty good place. This is basically what I did, and it was copy and paste, as it usually is with Red Hat documentation. So as long as you follow through with this, you'll have a running registry. It's like 5 steps. It's really straightforward. All right, 6, 7 steps. The thing that might catch you out if you're using your own registry with your own self-signed certs is to do this. So I'm totally off on the side now, and this is why I stay scripted. I'm having a little bit of a play around with GitLab runners and running the install as a pipeline through GitLab runners. Works great, by the way. But one of the things that I've had to remember to do was to copy the CA cert here and then update the CA trust inside of each of my containers. Otherwise, it wasn't trust in the registry. But that's not too big of a deal. Okay, so let's get down to the brass tacks. So we're going to go ahead and get the release. So if I go back to my WSL2 here, and what I'm going to do is literally just wget bam. The other reason why I'm mirroring the registry is there's about 2 gigs of containers or so. My internet isn't massively fast, so it makes the installation quite slow. I like my installation to be a bit faster, so by mirroring it actually took my installation time down from about 1 hour 45, 2 hours to about 45 minutes. So it's worth it for the 15 minutes it takes you to stand it up. It's well worth it. Okay, so we've got the OpenShift client here, so I'm just going to go ahead and extract it in place. I've already gone ahead and copied the client over to my user local SBIN path, so I can just do that. However, for the interest of this, we will use the local version of OpenShift client. So you'll see that it's this 28th of March client version, which is fine. That's the one that we just grabbed hold of. You'll see here. So it's not like I'm, trying to do some magic in the background. So the next thing we're going to want to do is we're going to use this to pull down. No, we're not. We're going to use this to mirror the repository. So if I go over to my, I've got a problem lately with Visual Studio Code just randomly deciding to crash itself. It's very annoying. Okay, so what we're going to go ahead and do now is we're going to mirror the registry. So I've got a script that I've already kind of picked up here, and it's just based on the code here. So if you look here, mirroring the OpenShift container platform image repository, there's a bunch of variables. There's a command that actually you run to do the mirror, and then there's finally a command that you do to extract the installer from your mirror. If you don't do this, if you use the already prepared installer, and you don't extract it from your mirror, then it's not going to install from your mirror. It will do some stuff from the mirror, but not all of the installation. So just kind of bear that in mind. But what I'm going to go ahead and do here is if I copy, so I'm going to just update my OCP release version. So if I go over to here, I'm just going to, well, let's click on it. Just going to grab that. And then go back over here, update my variable. So this is the version of Openshift OKD4 that we're going to grab. This is my local registry host address. So this is the registry I've already set up. I've already prepared that. This is the registry name. So we're running it. The registry is called Origin. Same as the remote is also called Origin. So you can find that out. It's this part of this string. So when this goes on to key, or quay, as Red Hat call it, I don't know why they decided to call it quay, but when it finally goes on to quay, the repository is actually called Openshift, not called Origin. So again, bear that in mind. Okay, so we've updated that. We've got a Docker. So one of the files that I've got here is a docker config.json, and all this is a base 64 encoded string that contains my username password for accessing the registry. And that, as it happens, I will show you what it looks like. I'll close cluster 2 because that was me testing. Here we go. So it's literally just this. So you should be fairly familiar with this. You've got an email address, which is just whatever you want, and then it's got username password. As it happens, that username password is that string, OCP:OCP. It's not really a secret. It's just an OpenShift mirror for me. And so if we, the release name as well, it should be release, unless you're pulling from here, then I believe it's OKD. I need to double check that. But if I copy and paste this, I'm just going to export these variables so that I can use them in my shell here. And then I'm going to go ahead and run this ocadm release mirror command. So all we've done right now is set some variables and grabbed the OpenShift client. In fact, just so that I'm using the latest version of the client that we've just grabbed ourselves, I'm going to do, whoops, of course, it's because I copy and pasted it. Silly me. Should have spotted that. Can't get the staff these days, can you? Right, let's try again. Copy and paste fail. There we go. Okay, so what this is going to do is it's going to use those variables that we've just set, and it's going to push my new content up to the registry. So let's watch that happen, and we'll come back when it's done. Okie dokie, so our mirror process has completed. So let's take a little look at what's going on. In fact, I'll make this a bit wider so we can read it. And let's have a little look at what's going on. So it's told us that there's 112 images that it needs to mirror, and it's going to mirror that to our internal registry here in the repository origin. And so it's going to tell us these are all the manifests that it wants to mirror. So you can see there's a bunch of OKD4.4, and you should notice this all matches up with the version that we're going to install as well. So once it's gone and done the planning bit, it's then going to start. So it took 34 seconds for that, not a lot of time. It then starts downloading and uploading them. So as it happens, I've already mirrored this repository, so actually it was just a bit of a demonstration more than anything of how to do it. But you'll see that it's gone through and it's uploaded all of the images there that it's planned. So if we go down here, mirroring complete, it took it's at 4.38 seconds. Now, what this does is comes down and so it tells us to use, or as part of our installation, this image content sources, or if you've got an existing cluster, then you can create this resource in your cluster so that your cluster knows, for example, if you're doing an upgrade, you do your mirror, you create this resource in your cluster, so it knows where to find your repository, where to find the images. So I'm going to copy this string here, and I'm going to go back over to our install config, and if I scroll down and put that in there like so, we've got the latest version of the install config with the important bit is this, actually, just to make sure that you've got the right version. If you decide to install other versions, this is the only part of that string that really seems to change. So let's just talk a little bit about the install config. So because we're using a mirrored registry, I've put the CA cert here in this additional trust bundle option. This is important, otherwise your install won't work. We're setting a base domain. So the base domain for me is cws.land. I'm setting a bunch of compute settings. It's probably worth calling out at the moment, the oVirt compute doesn't seem to have any customization, so we have to make some changes as we go down the installation path, but I'll show you what those changes are as well, because it's a little bit frustrating that they're not there. But at least we've got an installer that works, which is really good, and it's pretty reliable as well. Okay, so we set some metadata. So the first bit that we're going to want to change is this cluster name. So as it happens, I've created all my DNS records like api.test1.cws.land. You should see where I'm going with this. So your DNS records need to match this name, which is this part of your address, and the base domain. So api.test1. You get where I'm going with that. Networking wise, make sure that you set your cluster network, machine network, and service network. And for some reason, the Openshift install itself for oVirt, if you go through the interactive install, which does exist now, it will create something. It's OVN Kubernetes network type or something like that. So the builds I've done, I haven't had any success with that yet. So I've been retaining OpenShift SDN just because it works. Hopefully at some point that'll get fixed. I must admit I haven't raised a bug report for it yet, so they probably don't know that it's broken, which I probably should do. So then we get to some of the interesting bits. So I won't show you the rest of this, but if you this secret here, so that we've got our pull secrets. The first pull secret here is just the username password for accessing our registry, our internal registry. The second one, this cloud.openshift.com. If you're really cheeky and go to cloud.openshift.com and register for an account, you will get access to Red Hat's registry for 60 or 90 days or something, just to try it out. So I'm using it here because the samples were still using the Red Hat repositories. They were the Red Hat samples, and it was frustrating me a bit that I was having to go and correct those. So rather than correct them, while we wait for the upstream OpenShift samples operator to be fixed, I've just stuck that in there, and it does the trick. I've loaded in an SSH key. So this is a public SSH key to allow us to SSH into the nodes that we provision with the IPI. And finally, we've set some oVirt platform settings. So earlier on, I told you that I've reserved 3 IP addresses. When I say reserved, I just mean that they're not in use on my network. So the first is the API VIP. So it's the oVirt will deploy as part of the installation here a Keep Alive D cluster. So it'll take care of all the load balancing. It'll take care of making sure the IP address is highly available and all that kind of stuff. And they've done a really good job here. This is really slick. I really like how they've done this. So you'll end up with Keep Alive. You'll end up with Core DNS being deployed, multicast Core DNS, and you'll end up with a HA proxy load balancer as well. If you set the API VIP, this is what you want your API cluster name and API int.cluster name to point at. The second IP address, this DNS VIP, we just need to provide it an IP address that isn't in use on our network. So in my case, I've just given it .41. The DNS VIP again gets grabbed hold of by Keep Alive D, and it becomes highly available and all that kind of stuff. And that's so that Core DNS can service DNS requests for all of your cluster. So it does some really nice magic with DNS inside of the cluster once you've got it. Once you've kind of gone through the installation procedure, it's quite nice. Makes it really lightweight, really low effort to maintain. And finally, we've got the ingress VIP. So this is where your load balancer for actually accessing the applications on your cluster goes. So in this is your apps wildcard apps dot cluster IP address, and so this is where your applications are accessible. And that pretty much covers the installation config. It's really straightforward. There's not really a lot in there. I did find it a little bit difficult finding a good example of this. But I'll publish something up somewhere. Maybe I'll chuck it in the description or something. If you're not installing from a content mirror, then you don't need to have this image content sources section, so don't worry about that. And you also won't need this additional trust bundle if you're also not installing from a mirror. Okay, so we've mirrored our repository. Next thing that we need to do is go ahead and extract our installer. So the installer is a little bit special because it's got the address of all of the images built into it, so it knows what the installer itself, from a release perspective, knows exactly what images to go and pull down to have a successful installer, and that's part of how it bootstraps a cluster. So we need to run a command, which is also part of the OC client, to literally go and update the installer. And so all we got to do is OC ADM, pass it in the Docker secret for our registry, release extract, command Openshift install, and then this string here, these variables. If you remember, we copy and pasted we exported a load of variables that told it where our registry is and what the repository was called and what the release name was. Well, all we're doing is passing those variables back in. And this is going to go ahead and extract the Openshift installer for us. Okay, so that's our installer extracted. So if I do this, we can see that we've now got this Openshift install command. And if I go ahead and just do Openshift install version, we should see that it's the version that we expected. There we go, 10 so April the 10th, and then 18, 21, and 15 seconds. And we can see that the release image that it's pointing at is in our registry. Great, so we know that it's going to come from the right place now. So the last thing that we're going to need to do before we can actually kick off the install is just to make sure that we've got the oVirt config in place. So the oVirt, so the installer expects one of two things. Either you can put a oVirt config file, so it's expecting oVirt config.yaml. Either you can put that in a location of your choice and export a variable. So you can export oVirt config, and then you can just tell it where to find your oVirt config. Or you can, as I've pretended to do, but not really because I've taken my username and password out, or it expects it to be in the default location, which is your home directory .ovirt/ovirt config.yaml. So if we take a look at this, there's a couple of fields that we need to put in here. So the first is the address to your hosted engine. So in my case, ovirt.core.uk.eti.io, ovirt-engine/API. Brilliant. It expects a username. So the username needs to have enough privileges to be able to create machines, add disks, connect to networks, that kind of stuff, and also delete things, because your OpenShift cluster is going to interact with your hosted engine. You need to set a password, so I've put my totally real password in there. In my case, I'm not using a centrally trusted CA yet, so I've just told it to be insecure. So basically just don't do your SSL checks. And finally, I've passed in a CA bundle. So this is a little bit counterintuitive, saying that it's insecure but also passing in the CA bundle. And so it turns out that if you don't pass in the CA, so this is dead easy to get from your over hosted engine instance, but if you don't pass this in, then your install fails. So it will do the installation, but the cloud credential operator will fail to give your put the credential in the right places. So just kind of be a little bit wary of that. But that's all you need. That's all of the configuration that we got to do. So now what we can do is we're going to go ahead and run the installation. So Openshift install, create cluster dash dash dir equals cluster test1 OKD dev. So before I hit enter on this, I said that's all we got to do, and it kind of is. That's kind of true, but it's also kind of not. So one of the kind of weaknesses so far with this installer is that it's not really possible to configure defaults, sensible hardware defaults inside of oVirt. So things like your CPU, your memory, and your disk space. So because it uses the Fedora CoreOS image, and out of the box that image has an 8 gig disk, that 8 gig disk isn't big enough to run a master in any kind of any kind of real way. It causes problems. So what I tend to do, and what we're going to do now, is we're going to run the installer first. So we're going to run it once. We're going to let it go ahead and create a template. So the installer is really good because it will go off to the Fedora project here, as we can see. It will go and pull down the latest version of Fedora CoreOS. So in this case, it's going to pull down the March 10th release, the QCOW image for us there, and it's going to put that into OpenStack. It's going to put that into oVirt for us. So I'm going to go ahead and let this happen. I'm going to let it create the template, and then we're going to modify it for our installation. So we'll be right back once that happens. Okay, so I've gone and killed this. I've just Control-C'd it, the creation. And so I've got a template that it's created over here, and it's called, here we go, there we go, test1 K2LP RHCOS. So what we're going to do with this, we're going to create a new VM from the template. I'm probably cheating a little bit with this, but actually I've already done this one. No, I haven't. So you can see here that it's just a 8 gig virtual disk, and we need to extend that. I don't know a way of doing that just with a template, so we'll create this new VM anyway. So we'll call it, we're going to set this to be CoreOS. Actually, let's do the customization in the VM. So test1 FCOS test1 image. Okay, so image is extracted. So what I'm going to do is I'm just going to go into this virtual machine that we've created from that and just edit it. I'm going to do. I'm just going to set the operating system. I'm going to set this to CoreOS. Where's CoreOS? No, it's here somewhere. There we go. Red Hat Enterprise Linux CoreOS. That's good enough. I'm going to say that it's a server and not a desktop. That does some stuff with memory scheduling and overcommits and stuff like that. Instance images, we don't need to change that just yet. Network, so I want it to be on that network. If you've got instances that you want to be on different networks, you'll need to have a different template for it. So just kind of bear that in mind as you're structuring things. So if you've got maybe you've got a worker group that you decide to deploy into your DMZ or into a particularly restricted area of VLAN or area of your network, you'll need to have a separate template to represent that. But it's really not a huge deal. So we'll go ahead and we'll save those changes. Now we're going to go to disks, and we're just going to extend this disk here. So if you right click on the disk that you want to extend and go to edit and then extend by size, we're going to say extend it by 92 gigs. I like a nice round 100 gig. So if I do that, it'll extend the disk for us. Now once the disk is finished extending, we're going to repackage that back up into a template, and then we're going to tell the installer which template it should use. So we'll just wait for this to do its thing. There we go. So what we'll do is go back to our machine, and we want to make it a template. So just in case you missed that, burger menu, make a template, and we're going to call this one FCOS test1. What should we? Yeah, just call it image. Call it the same thing. I want it to be on that data store with that profile, no quota against it, or the default quota. I want all of the defaults here. I want it to be in that cluster. Yeah, it looks good. Okay. So that'll go and package that up for us again. Now, while that's happening in the background, I'm going to go back over here. So in order to tell it to use a particular, or tell the installer to use a particular template there, we need to export another variable. So if I search for this, we've got a variable here called Openshift install os image override. If you don't set this, then by default it will go off and it will create a new template for you, which is good practice. There's absolutely nothing wrong with that. But because it's not possible yet to kind of customize some of the hardware settings and the disk that's available to it, it makes it a little bit problematic. And so I'd argue that you should create your own templates anyway, because you may have some customization that you need to do kind of to centrally manage these things. Maybe you've got an agent that you always install, or you've got a particular policy for something that you always install. Or maybe you just want to scan it and certify the image before you use it. So we're going to use this, the name of that template that we just created. So FCOS test1 image. We'll just set that as the variable. One other thing that we're going to have to deal with here, because we kicked off an install and then kind of told it not to, is if we look in the directory, we'll notice that the install config has gone. And so to get that back, we've got a bunch of metadata that's being used to generate the cluster. So to get that back, all we're going to do is is Openshift install create install config, and that'll go in. It will recreate the install config file for you based on the definition of the cluster. So if we go and look at that cluster directory again, we've now got the install config, which means that we can now go and clean up the rest of the data, the rest of the stuff there, because if you don't, you're going to have a problem. And we'll just run a install destroy cluster, and that'll just clean up all the Terraform files and all the metadata and other bits and pieces for us. So if we look in that directory again, we're left with just the install config. I think there is actually a log file that's hidden. There you go, Openshift install log, but it doesn't really matter to us at this point. So we're now ready to actually go and create the cluster. So if I go and run Openshift install create cluster against our directory, and then we're going to leave it for half hour, and we'll come back. There we go. It's using the override image. So we'll leave this for half hour or so, and we'll come back when it's deployed. But real quick, if I go back to virtual machines, we're going to see a bunch of machines here. In fact, I'm not going to disappear it yet, because there's something interesting that we should do. So you'll see here that the installer has just created a bunch of resources. So it creates the Bootstrap node. The Bootstrap node is a temporary node that is there literally to instantiate the cluster, and then it enrolls the masters into it and then deletes itself. And so once the masters are kind of all up and running, what you may want, or let's have a little look actually at some of the resources. So if we look at this, it's coming with 8 gig of RAM, 4 CPU cores. What I like to do here, once these instances are up, I like to give them a bit more CPU and a bit more RAM. Again, it's a little bit annoying that we can't set that in the installer yet. It might just be that I haven't found the option for it, and I'm sure that the options are on the way. The guys are doing an awful lot of work around that, and there's a lot of improvements coming. Just in like the last month, everything's improved massively. But unfortunately, it doesn't pull through those defaults for CPU and RAM from your template, just for the workers, just not for the masters. So if we look again at our master and go to our disk, we're pulling a 100 gig disk, which is awesome. That means there's going to be plenty of space for container caches and ephemeral storage and all that good stuff that we possibly want. Okay, so we've got our cluster, our instances running now. So I'm just going to go through them one by one. Edit. So it's not in the coming up state, this powering up state. It's up, fully up. I'm going to go into the System tab. I'm going to set 16 gig of RAM. I'm going to set 8 CPU cores, and I'm going to say that I want 4 cores per virtual socket, and we're going to have 2 sockets. If you do it this way, then it just applies everything for you at runtime, which again is quite a nice little handy thing, which is more of a feature of oVirt than anything else. So I'll do that for all of these instances. It's up to you whether or not you want to do it for the Bootstrap node. I tend to, just so it's got a little bit more horsepower. Makes the install go a little bit quicker, but if you're a bit constrained on space, then you don't have to worry about doing that. I just realized I didn't actually tell you how to set the number of workers at first install. So the installer itself only provisions your Bootstrap node and the 3 masters. The rest of the heavy lifting is done by operators inside the cluster, but you can tell the installer here by setting compute and the number of replicas, how many workers you want. I wouldn't necessarily go less than 3 for your control plane, unless I wouldn't go any higher either. There's kind of varying amounts of performance gain and loss, and there's all sorts of stuff that goes on. 3 is the magic number for your control plane, even on quite large clusters. You've got very few reasons why you need to change that. Usually it's just for scaling up or scaling down or rotating your control plane or something like that. Yeah, so just set the number of worker replicas in your install config. That's literally all it is. So as part of the install here, we're gonna see a few things happen. So CPU and memory being used by the Bootstrap. I'd expect the CPU to ramp up quite high for this, but what we're going to see in a minute is the Bootstrap node is going to reboot, and then probably a couple of minutes after that your masters then all reboot as well. That's a good sign. That means that it's pulled down any updates, it's pulling down packages from your container registry, and the install is moving and grooving. There we go, there's the first power down. The next thing that you'll see once your masters have rebooted themselves is they're going to start consuming quite a lot of CPU usage as well, quite a lot of CPU time, which again is a really good sign. It means that it's working, it's starting to build out the etcd cluster and all the kind of component bits for your control plane. But then probably about 15-20 minutes after that, you should then start seeing workers appearing. So my dinner's hit ready, so I'm actually going to take this as an opportunity to go and eat while we wait for the cluster to build. And yeah, we'll be back in about 45 minutes. See you then. Okay, so a real quick break for my dinner. Thai, by the way, delicious. Well excited for it. I've not had a takeaway in so long. So really quick, so we can see that the masters here have all done their reboots. They're all starting to show CPU usage now, which is good. And we can see that we're starting to get workers appearing in the cluster as well on our infrastructure, which is really good. If you've logged into the Bootstrap node and you're starting to follow along with the logs, don't be too concerned if you see lots of errors and things like that. Just kind of leave it alone for an hour in general, and it'll eventually get there. What I will do though is if I go back over here, so this is our installer. We can see here that it's waiting for the bootstrapping to complete. And if I just go over here, and then if I use our OC thingy-mabob, do pass it the kube config, we're going to tell it where to find that, because we've put it in the, where did we put it? In the auth directory, and it's called kube config. Like so. If we take a little look, there we go. And if we look at get nodes, hopefully we can see some nodes. Okay, it's pivoting. So once the bootstrapping's finished, it's going to hand over back to the masters. So it'll be kind of the next milestone. Oh, there it goes. It's pivoting. So we'll see Bootstrap here will complete, and hopefully if we get nodes, there we go. We can see that all of the masters are up, they're ready, they're healthy. And if you want to really play along, you can start doing get pods, all, namespaces. And you'll see there's a bunch of stuff that's running. Don't be alarmed if you see any errors. There's things, so as a kind of principle, it just throws everything to start, and there's certain things that won't start until its dependencies, the things that it requires, have already started. So don't worry about that. But you can see as a general rule here, things are starting, they're running. You can see the installers are happening. So yeah, just grab a coffee, let it do its thing. You can see here this install, the error that was down here has disappeared now. And yeah, just let it do its thing. So yeah, see you in about 20 minutes, something like that. All right, so back to the install. So cluster's up, cluster's done. It took 30 minutes from the master restarting. That's not too bad, and we've got 3 workers. So let's take a little looky look. So if I take hold of this, and we'll just accept the cert issues. Whoops. There we go. Right. So we're going to log in with kubeadmin. So it's you get a account out of the box with a randomly generated password. It's recommended to set up some authentication and remove the kubeadmin user. But if we log in, we've got a working cluster. Excuse me. These things we can ignore. So it's telling us a couple of things that are quite useful. One is that the alert manager doesn't have anywhere to deliver alerts to. This is quite a nice feature because it means that you can deliver your kind of alerts and things that you configure inside of the cluster for maybe applications going down or disks filling up to be delivered to something like a webhook or Slack channel or wherever you want. And then this is just telling us that the image registry isn't set up. Now, out of the box with an oVirt cluster, you don't get an image registry, and that's because we don't have any storage configured. So before we can have a working image registry, we're going to need to configure storage. Now for storage, we're going to use a utility called the oVirt CSI driver. Okay, so we're going to be using this oVirt CSI driver that the oVirt crew have been putting together to support OKD, and it works really nice. What I would say is there's one thing that we'll need to change, and I'll show you what that is, just so that it becomes the default storage class, but that's not a big deal. All we're going to go ahead and do to use this is if we go and clone our repo, so git clone. Okay, so we've got our CSI drive. So if we change into the directory here, and all we're going to do is going to deploy, and what we're going to want to do is just walk through these files here. So all the CSI driver does is creates a bunch of resources for us, which is quite nice, and I can't remember which one we need to change by default. So this annotation section here, this should be underneath metadata. So I'm going to go ahead, and what I'm going to do, I'm going to copy it, delete, whoops, delete. There we go. Yeah, it's just otherwise if you don't do that, then you will end, whoops, don't want to replace. What am I doing? If you don't end up doing that, then your storage class won't be default. You'll have to go and create this annotation by yourself anyway afterwards, but we'll just do it here. So the only parameters that you're really going to have to change here is the storage domain name, which if we go and take a look at our oVirt cluster and go to storage domains, So we're going to tell it to use this UK FreeNAS Silver 01 storage domain. Bush, just like that, and thin provisioning we're going to leave to true. Now you're going to say, well, we haven't created any credentials, and that's right, we haven't. It's because, so your credentials, they get created, this is the right cluster, they get created as secrets in Kube system. So over here there's a secret called oVirt credentials. There we go. And so this credential, so this secret has a bunch of values. It's got the CA bundle that we specified. It's got the insecure flag. It's got password. It's got the address. It's got the username. And what happens is there's an operator in the cluster called the cloud credential operator. This one right here. And if we take a little look at the logs, you can see that it's going through all of the namespaces and looking for a custom resource called a credential request. And when it sees a credential request, it'll dish it out. So our oVirt CSI driver here will go ahead and request a credential as well. You can see that this item here is a credential request. So what we're going to do is config. You can actually set your kube config path as an environment variable as well if you wanted to not have to pass this in every time. It can be useful. And what we're going to do is we're going to create -f because we're going to create a bunch of files, and the files we're going to create is CSI driver deploy CSI driver, and we're going to just pass the OC command a directory, and what it'll do is it'll go through each of the files in that directory and create the resources for us. So that's all successfully been created. So if we go back here, we're going to see a new project called oVirt CSI driver, and if we go into the project and take a look at the workloads, we can see we've got a daemon set which has the node pods, and what these are doing is making sure that any storage that is requested to be available, requested to be attached to a particular what am I trying to say, a particular worker node, it will make sure that it gets attached, mounted, all that kind of good stuff. We've also got a pod here which is stateful set, which is your CSI plugin, and this comes with a number of containers as part of it, but this is essentially what's doing the communication with oVirt hosted engine and making sure that disks are created, disks are removed, and they're formatted in the right way and all that kind of good stuff. So that takes care of it. Okay, so these pods have now initialized. It took a few minutes actually to do that, but I didn't need to kill or restart anything. You can see 0 restarts, 5 minutes. And so, yeah, so these pods have a number of components. We've got a couple of containers, and the init container just to set things up, and then a couple of CSI containers which just come down from the Kubernetes CSI project there. And then the actual thing that makes the dream happen, which actually does the interaction with oVirt for us. So if we go back to our test project over here and go to storage, and take a quick look at storage classes, we've got a new storage class here called oVirt CSI SC, which is what we've just created by deploying this, and we can see that it's also the default class, which is awesome. If you ever wanted to change our storage domain, we just do that. We just change it here. But if we now go over to a persistent volume claim, so we've got an application and we want to try it out, so let's just create some storage. Persistent name test. So well worth calling out here that this only provides read write once. It's only single user mode. There's no shared access and there's no read only access, and that's because it's block storage. But if we take a look there, you can see that it got bound to this PV, which was created on the fly for us, and this PV exists in the back end. So if I where's our reference? This is our volume, I think, for, yeah, I think this is the one. So if we go back here, in fact, if we take a little look at events, do we see, there you go. the disk was successfully added. In fact, if I go to disks and search by disks, we might even, no, wrong ID. Whoops. In fact, it's probably just going to be this, isn't it? Is it going to be sensibly named? Is it possible? It is. It's sensibly named. And that's actually the ID we just searched for, I think. Yeah, it is. That's just the ID that we just searched for that didn't show anything up. But anyway, as we can see, it's successfully created the storage. Excellent. It means we can start doing some useful things. So the next useful thing that we're going to need to do is set up the registry. So if we go to our projects and we're going to go to the Openshift image registry project here, and we just have a little look at workloads, we can see we've got the operator deployed here, but we don't have a registry. So the operator is watching for a particular cluster resource. So we're going to take a look at custom resource definitions for the registry. And what we're going to do is just have a little look at this config one. And we're going to take a look at the instances of that. And we're going to go ahead and edit it. So there's a couple of things that we need to change with this reload. And so this is quite annoying because it keeps reloading the object. It means that you're never really going to be able to change it in the GUI. So what I've been tending to do with this is actually editing it by CLI, which is a little bit more fiddly. But if we go and change our project to it's in the image what is it? It's the Openshift image registry project. And then if we edit, and then the resource type that we're going to edit is was it config./cluster, I think it's called. Yeah. Okay, so the object itself is called cluster, and the resource type is image. It's a config.imageregistry.operator.openshift.io. So if you edit that, I'll show you again in a second. And what we're going to do is a couple of things. So first of all, I'm going to change the default route because I want my registry to be available from outside of the cluster. Not going to disable redirect. Don't care about the secret. Management state. So management state needs to be managed. We don't need to set a proxy because I'm not using a proxy here, but if you were, you'd modify these parameters. We're only going to have one replica. Request we're not going to mess about with. Rollout strategy we're going to want to be recreate. If you try and use rolling update, because we're using read write once or single user mode storage, you're going to run into a load of problems and it's just going to be really painful. Storage wise, if we go here and we create a PVC and claim, and we're going to call the claim image registry storage, then we'll go ahead and save that. Now you're going to tell me, well, Craig, you haven't created the storage for it yet. And you're right, I haven't. So we're going to go over here to persistent volume claims, and in the Openshift image registry project, if we create a claim, and we're going to call it registry storage, you might be cracking my code here. We'll create some storage for that. I'll give it 20 gig. Bish bash bosh. There it is, that's bound. And then if we go to the workload in the project, so take a little look at the operator. The operator should complain that the storage wasn't there. Whoa, it's doing lots of things for us. Don't care about cloud provider. Yeah, there we go. So we can see it's doing stuff based on the logs there. If we go back to pods, we'll start seeing there we go. A ton of pods have just been made available for us. So once this is started, that means that we'll then be able to deploy a sample app. So we'll do that next. Okay, so that's the registry up. So if we go over, we go back to our AAA test project here, and I'm actually going to drop into the developer mode just because I'm a bit lazy, and I'm literally just going to deploy something from the catalog. I like to deploy from the catalog. Haha. Oh, it's because it's filtered. I thought I was going to do something really stupid there, or I was missing something. Okay, so I like to deploy from the catalog just because it's a pretty easy happy path test. It helps test whether, from a development perspective, you're going to be able to build, you're going to be able to push to the registry, you can deploy containers, you can do all the things that you want to do as a developer. So all I'm going to do here is quickly instantiate this template. And it's really nothing fancy. It's just the default options. We'll just hit create on that, and yeah, so this will go off. It'll request a storage for us. It'll go ahead and pull down the database container there, and it'll go and do a build. If we look over here, it'll pull down and do a build and do lots of fun stuff for us. Until finally it deploys the application. So I'm going to leave this to do its thing. Alrighty, I just thought actually, while we're waiting for this to build, what I'm going to go off and do is just add another worker node to the cluster. So it's really easy if you want to provision some more resources here. Just go off to machines and, machine sets. And we've got a machine set called worker 0. Now you can either I guess you could clone that and create another worker set. Oh, now that's interesting. So, okay, so MySQL's running. MySQL is a good one because this runs with a persistent storage. So there's a persistent volume here, which, just to show there's no magic going on, we've got the storage is coming from this storage class that we've just created, which is this persistent volume, which comes from the CSI provisioner. So that's quite nice. As I said, I like deploying this template because it just shows the happy path of everything. It shows that you can build, it shows that you can deploy, it shows that you can attach storage. It's just quite a handy little test to run. So let's take a little look at what's going on with the deploy. So this should be, although it's called MySQL persistent, the demo itself is actually called CakePHP MySQL persistent. So this should be pulling down our, yeah, there we go, our application. And just like in Openshift 3, if we go to builds image streams, we can see that in our image stream, in our project, we should have, there you go, a container which is built. And if we go to the builds, we can see that our build was complete. So the build happened. In fact, let's see if we can see the logs for that. Can we see logs? Nah, it's not retaining the logs. Of course, there's no logging deployed yet either in the cluster. Back here, yeah, there we go, running. And if we go back to developer view, we can see the little blue rings there. The build is green, the build's complete, and as soon as that ring goes blue, come on, I mean not ready, there we go, bush. There we go, we have our application, we have liftoff. So that's basically taken us through a full installation end to end. We've done a little bit of testing here. We've configured storage, we've configured the registry, and yeah, that overall is a pretty happy cluster. It doesn't look like there's really anything there. I mean, the only thing that I'm looking at here that's a bit weird is this machines thing. Ah, there we go. They're coming into the cluster now. So the whole provisioning thing actually works. It's just for some reason the machine and the node aren't getting tied to each other. But yeah, overall it's working. We've got applications, we've got everything else should work for you. So I think we'll call it a day there. I've got another video in the pipe. In fact, I'll probably do it straight away on how to deploy just a container, just an application from Docker Hub into this. But yeah, hopefully this has been useful. What I'll try and do is get the example configs and things like that posted up somewhere. try and maybe stick them on GitHub or something like that. Should be good enough. And yeah, anyway, hope everybody's keeping safe. Hopefully that was interesting. And yeah, let me know what you thought of it in the comments. Like, subscribe, share it with your mates, that kind of stuff. Otherwise, take care, everybody. Stay safe, and bye bye.